Okay, let's unpack this. We look up at the night sky, see this universe just packed with, well, potentially habitable planets orbiting billions of suns, and the big question just echoes back, where is everybody?
Hmm.
This baffling silence, the Fermi paradox, that's our focus today. Why haven't we picked up any signs of other intelligent life out there, given, well, the sheer cosmic real estate?
It's a question that really sparks endless curiosity, doesn't it? And
Yeah.
for this deep dive, we've pulled together a pretty rich set of sources to explore some, compelling possibilities.
Okay.
We're looking at scientific research that's grappling with the probabilities,
Mm-hmm.
studies that even try to explain why the paradox might not be a paradox, really, and even some uh, imaginative ideas from the science fiction world.
Right.
The goal is really to navigate this cosmic quiet and maybe get a better handle on why we might be alone, or, at least why we haven't found anyone to chat with yet.
So let's start with just the scale of it all.
Yeah.
Our Milky Way galaxy, I mean, it alone has billions of stars like our own sun.
Yeah,
Billions.
it's staggering.
And what's really striking is the growing evidence suggesting that a huge number of these stars have planets orbiting them. And many are in that habitable zone, the Goldilocks region, right? Where temperatures could allow for liquid water.
Exactly. And what's fascinating, kind of adds another layer, is the timeline. Many of these star systems are far, far older than ours.
Billions of years older, potentially.
Imagine that billions of extra years for life to maybe emerge, evolve intelligence, and maybe even develop civilizations that could, send out signals or explore space.
Which just makes the Fermi paradox even more pointed, doesn't it? All this vast potential, this immense timescale. And yet, the cosmos we actually observe appears starkly, well, empty of any obvious signs of advanced alien life. Anyway, it's a real disconnect.
It is. And this is where the Drake equation often comes into the conversation. It was an attempt, formulated by Frank Drake, to estimate the number of detectable alien civilizations,
Wow.
basically by breaking the problem down into a sequence of probabilities.
Right, I've seen that. It takes into account things like how many stars form, what fraction have planets, how many of those planets could support life. It's quite a list of factors, isn't it?
It is, yeah. It includes the rate of star formation, the fraction of stars with planetary systems, the average number of habitable planets per star,
Mm-hmm.
then the fraction of those planets where life actually arises. That's a big one.
The origin of life bit.
Yeah. Then the fraction where intelligent life evolves, the fraction that developed technologies we could potentially detect, and finally, sort of the average lifespan of such a technological civilization.
Okay. Okay. It looks very scientific on paper, the equation.
Hmm.
But the crucial insight here, I think, isn't the formula itself, but the stark reality that most of its key ingredients, especially, like you said, the likelihood of life starting, are just complete unknowns,
Precisely.
which means any result is less a precise calculation and more. Well, it just shows how profoundly ignorant we are about these steps.
Exactly. While our understanding of, say, the first few variables like star and planet formation, that's improving rapidly. The last four, particularly the probability of life arising, what scientists call abiogenesis,
Oh.
Life from non-living stuff, and then how long advanced civilizations tend to stick around,
Yeah.
those are shrouded in mystery.
Mm-hmm.
We just don't have the data. We can't plug in meaningful numbers.
So it's like trying to guess the outcome of I don't know, a complex recipe when you don't know what half the ingredients are or how they even interact.
That's a very good analogy, yeah.
Yeah.
Because these unknown variables, you can assign wildly different values to them, right?
Yeah.
So the Drake equation can spit out estimates ranging from, well, practically zero alien civilizations all the way up to millions.
Yeah.
It really just underscores how much we don't know.
And there's a point, I think I read this, that the Drake equation can sometimes give this misleading sense of certainty. Like we're calculating something solid when we're really just making educated guesses about things we barely understand, like how life even gets going in the first place.
That's a critical point. It's sometimes called the overconfidence effect. We have this tendency to assign probabilities to events like abiogenesis, even though our actual understanding of the process is still, frankly, very limited. Estimates for the likelihood of life popping up on a habitable planet can vary by just enormous margins, orders of magnitude.
Which brings us to some more recent research that takes a rather sobering perspective on this. I remember reading about a 2018 study suggesting that when you really properly account for the realistic uncertainties in all those Drake equation parameters, well, the probability of us being the only intelligent life in the observable universe actually becomes quite significant.
Yes, research aimed to sort of dissolve the Fermi paradox
Right.
rather than offer a single solution. By focusing on the sheer range of uncertainty in those key parameters, especially the chances of life originating, that's the F-subtle term,
Right.
they concluded that even if you make pretty optimistic assumptions for everything else, the massive uncertainty around just that initial spark of life, well, it can still lead to a high probability that we are, in fact, alone.
Wow.
So maybe the silence isn't really a paradox we need to solve.
Hmm.
Maybe life, particularly intelligent life, is just exceptionally rare.
Okay, that's a truly mind-blowing idea. But okay, let's consider the alternative. Let's say life can arise relatively easily. Why the continued silence then? This is where the great filter concept comes in, right? Like some kind of cosmic bottleneck. Either we've already squeezed through an incredibly narrow passage just to get here as intelligent life, or maybe an even tighter one is waiting for us up ahead, threatening our existence.
That's the core idea, yeah. The Great Filter proposes there's some critical stage in the development of life, or perhaps civilization that is incredibly difficult, maybe even practically impossible to overcome.
Mm-hmm.
And this filter could be behind us, meaning we've already cleared some extremely unlikely hurdle.
Making us incredibly lucky or special or something.
Or it could be ahead of us, representing a challenge that most, perhaps all, advanced civilizations ultimately fail to navigate.
Okay, so if the filter is behind us, what kind of incredibly unlikely event are we talking about? Is it that very first spark of life itself? A biogenesis? Or maybe the long, complex process of evolving intelligence?
Those are definitely the leading candidates. The fact that all known life on Earth seems to share a common ancestor, that suggests abiogenesis might be an exceptionally rare event. Perhaps it only happened once in the entire observable universe, right here.
Just ones.
Maybe. And even if simple life emerges, the leap to a complex, intelligent life and then onto a technological civilization capable of things like interstellar communication, well, that might involve a whole series of profoundly improbable steps, too.
You mentioned earlier, it stuck with me, that animals have independently evolved the ability to colonize land multiple times.
Right.
But something like human-level language, theoretical science, that seems to have arisen only once here on Earth. That really puts things in perspective.
It does.
And I recall reading, dolphins have had millions of years, they have significant brain size, but they haven't exactly been building radio telescopes, have they?
Precisely. A large brain doesn't automatically mean technology or, the drive for interstellar communication. And as another source we looked at highlighted, out of all the species that have ever existed on our planet, only one has become spacefaring. And let's be honest, we're still in the very, very early stages of that particular journey.
Yeah, barely dipped our toes in.
So the path to becoming a detectable communicative civilization might just be an extraordinarily narrow one. Maybe that's the filter we passed.
What if the great filter is ahead of us? That feels like a much more unsettling prospect. What kind of universal barrier could be waiting out there to essentially take out advanced civilizations?
The possibility that gets discussed most frequently in this scenario is, well, self-destruction.
Ah,
The idea is that as civilizations advance technologically, they almost inevitably develop the means to wipe themselves out, whether they need to or not.
like nuclear war, I suppose. That's the classic fear, isn't it?
That's certainly one potential path, but the sources we examine point to other dangers too. Things like unchecked depletion of essential resources leading to catastrophic climate change,
Which sounds depressingly familiar.
indeed, or unsustainable levels of energy consumption. And as one study suggested, even if a civilization makes a full transition to clean energy, if its overall energy demands just keep growing too rapidly, they could still trigger runaway global heating.
Wow, okay. I hadn't really considered that specific angle on clean energy. It's not just what energy, but how much.
It's about the total planetary impact. An astrophysicist, Adam Frank, he actually created computer models simulating the rise and fall of hypothetical alien civilizations based on energy use and environmental impact.
And what happened in the models?
Well, in many of his simulations, these energy-intensive civilizations ended up collapsing due to environmental crises. The ones that tended to survive long-term were those that recognized the danger early and made a swift, decisive shift towards sustainability.
That's a chilling thought, especially given our own, ongoing struggles with climate change and resource management. It almost feels like we might be walking down a well-worn path towards self-destruction.
And there were other potential self-inflicted wounds, too, things that were mentioned, like the misuse of powerful biotechnologies, maybe accidentally creating dangerous synthetic life forms, or perhaps the development of artificial intelligence that becomes, well, incompatible with its creator's survival.
Right.